And in this slide, we will first talk about the integers, which doesn't have any decimal points, any fractions. It's just integers. And also we will try to, define base 10 numbers in binary form, which means base 2 actually, because it only has 0 and 1s, as you can see here. This is also called binary form or base 2 form, let's say. Let's show how the integers can be used on computer, how they can be represented on a computer with base 2 systems. And the most straightforward approach, called the signed magnitude method. This is actually signed magnitude method because we have a sign at the beginning. The first bit, these are bits in the computer, and this is the word, or this is a word, it doesn't matter. But the first bit is the sign, and the rest shows the number in base 2 system. And for the sign, 0 is positive and 1 is negative. Here, for example, it's 1, that means it is negative. And the numbers are defined as 0 and 1s as well. And we will just start from 2 to the power 0 here and increase it by 1, 2, 3, 4, etc. and sum them all to get the final value. Here, this example is representing 173 with a minus sign at the beginning, and it's a 16-bit computer because we have 16 bits here. The 15 bits are for number, 1 bit for the sign. So simply, we can define this to the power 0, to the power 1, 2 to the power 2, 3, 4, 5, 6, 7. You can see from after 7 actually we have zeros because the number is small. This shows that an 16-bit or a 16-bit computer represents much greater values. By adding ones here, we can have greater values than the 173. Let's define this. The sign is negative because it's 1. And here, 1 times to the 0. This is actually 1. 1 times to the 1, 2. 1 times to the 2. Sorry, this is 0. Let's define this way because it's 0. This is 0. 1 times 2. This is 4. 1 times to the power 3. This is 8. This is 0. Let's don't deal with it. This is 1 times to the power 4 and 5. This is 32. This is 0 again. And this is 1 times to the power 7. These zeros has the powers as well. That's why we need to increase it at each digit. This is 128. And if we sum these, it will give us 173. And with the minus sign, it is minus 173. In the example here, we will define the range of integers defined in a 16-bit computer. And in the bits in the computer, we will have 1 and zeros only. And with these, what are the numbers that we can represent in the base 10 system? Let's try to find them. For that, let's first draw the 16-bit system. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, actually up to here. So I will need to remove these parts. Okay, 16 bits. And the first bit is the sign. This is sign. Rest 15 bits number. So this is 16 bits. Let's say. And let's try to find the maximum value. And for the maximum, these 15 bits should be defined as ones, because we only have 0 and 1s here. With ones, the max number, actually if the sign is 0, it becomes the maximum value, which is, we can define as 0, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 12, 1, 1, 1, 1, 16. As you can see, this is the 16 bits. And if we, calculate this, 0 means positive, and 1 times, this is from 0 to 14, 2 to the power 4, 2 to the power 14 plus 1 times 2 to the power 13, and it goes this way up to 1 times 2 to the power 0, which is this one actually, and this is this one. If we sum this up, the final result is 32767 in the base 2 system. And we can also define this as 2 to the power 15 minus 1. So for 16-bit computers, we have, if the beginning is 0, we have this value, this much number maybe we can say, or if this is 1, the beginning will be minus, so this will be minus. We can say the min is 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, and 1, 1, 1, 1, and it gives us minus 32767. So which means, let's say, so for 16 bits, or for a 16-bit computer, numbers, the range of numbers or integers are from minus 32767 to 32767. Plus, of course, we will have the 0 value. So these do not include 0. And that's why we will say plus 0. And we define 0 in computers with minus sign in the beginning, and the rest is 0. 15 zeros. This gives us 0. And of course we can define here 0 as well, which gives us another number, but we don't do that in computers. In computers we assume that 0 is defined with the negative sign in the beginning with 1, so no need for minus 0, or no need for, let's say, this 16 0. We don't need this. We just need this and these values. That's why, because the 0 is defined with negative sign, we say then the range is from, we increase the negative number with 1 only because we added 0, minus 32768 to the positives are the same. So here 0 is added with D, of course, to represent an additional negative number. It is not negative, it is just 0, but we represent it as as if it was a negative number with the sign notation here in the digit. So this is basically the main idea, showing the integers in a computer for 16 bits.